can't unmute myself. Thank you. Hi, everybody. Hello, hello. I hope you're all having a wonderful day today. I hope the music isn't too loud this time. I looked back at the VOD earlier today, and the music was so loud. Chat, why didn't you tell me the music was so loud? You hate hearing my voice that much, is that you'd rather listen to the music than me? Is that what it is? Fine. Maybe I won't teach you derivatives. No, that's what you want. I'm teaching you derivatives, okay? We're going to be studying for my math test I have to take later this week because I have to study and I don't want to do it alone. If it were up to me, I'd be playing video games right now. So, we're going to be doing some studying, some of the stuff. Okay, I'm making sure that that's a moving. I want to go here and do this. There we go. Awesome. So we're gonna be starting with. We're gonna start with our green. So we're going to be solving for these. I'm going to. I also have the basic rules of derivatives here, but I'm going to try my best not to look at them. It's kind of the point is, like, we're not supposed to be, like, looking at them and all, because we have to memorize them. So, I'm going to be trying not to look at them. But I can if I have to. If I really have to. We're gonna do a thing. We're gonna do a thing, and the thing is gonna be, I'm going to get that doc up on my phone, because I meant to do it earlier, but I forgot. I want to keep, like, the questions and all. That's not what I meant to do. Okay. Everything's fine. Okay, everything is okay. Beautifully done. So, if you don't know what a derivative is, derivatives, it is how you solve for the rate of change function of any given function. So there are specific rules on how you're allowed to do this. Actually, let's probably just make our first page here our rules list. So, we're gonna put the basic one in purple, and then we're gonna do the regular one in the derivative form in green. So we have our f of x, and that turns into our d over dx of f of x. This is our derivative. It's also shown as f prime of x. That's another way of showing derivatives. But we got c. We have x to the nth power, the square root of x, a to the power of x, e to the power of x, log base b to the power of x, not to the power of x, but times x, log of x, log base b of x. That is how that is said. I am dumb. Then we have natural log of x. So these are like the basic functions here. And so the derivative of c, c is our constant. C stands for literally anything. It could be 5, it could be 22, it could be 50 million thousand. As long as it does not include our dependent or independent variable. So if it doesn't include x, it's c, which the derivative of c is always 0. So easy to remember. The derivative of x to the n being any real number, would be the n we have to put in front, so n times x, and then we take n minus 1. So the power of n minus 1. And then the square root of x is 1 over 2 square root of x. Ah, that's not what I meant. See? Totally good. And then, then we have a to the power of x, which a to the power of x is a to the power of x times ln of a, the natural log of a. That's not what I meant to do. Make sense so far? Good. If it doesn't, good luck. Good luck. This one's the hardest one. This is the hardest one. E to the power of x is the hardest derivative ever. It is extremely hard. It is e to the power of x. E to the power of x. The derivative is e to the power of x. Mind-blowing. Like, this is next level math here. This is top-notch, like, mwah, mwah, beautiful math. Beautiful. Sarcastic. Log base b of x, b being any real number. This would be log, no, I was doing the wrong thing. This would be 1 over x ln rb. Yeah. And then ln of x is just 1 over ln. 1 over x. 1 over x. And so those are our basic ones. Those are the, like, easy ones that you can think that we can do. Now, there's also the trigonomic ones. Those ones are a little funky. The trig ones can be a little sussy. A little sussy baka. Okay, hold on. I'm gonna cut that off there. Just because I want to make it easier. Okay. Yeah. Okay. Now, again, f of x, f prime of x, those are the same. So I don't need that. I want to start on this one. So, we have sine of x. We have cosine of x. We have tangent x. We have cotangent x. We have secant x. And we have cosecant x. Beautiful. Beautiful, beautiful, beautiful. Okay. So these ones, we then turn this into sine of x is then cosine of x. Cosine of x is negative sine of x. Then tangent is secant squared of x. And cotangent is negative cosecant squared of x. And then second cosec are slightly wonky, because this is sec x times tan x. And this one is negative secant x times cot x. So these last two, they're a little wonky, but they still get the job done. So that's all that matters. Yeah, okay. Bum ba dum bum 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 bum. Hold up. Okay. Okay. There we go. I don't know, I felt something was off and something was, so I had to go fix that real quick. Okay. So, those are like basic rules. Those are basic and our trigonomic rules. Then we have to deal with the inverse trig rules. This is like arc sine, arc cosine, those kinds of stuff. And they're funny. They're funny. Actually, they're gonna go down here. There, okay. I'm gonna put them down here because they're a little wonky. So we start with sine the negative 1 of x. It's not technically sine to the negative 1. It's actually arc sine, but this is how it's like shortened down to make it easier to write. And I'm going to skip a couple lines and go cosine, arc cosine of x. Did I do my parentheses? No, I did not. Arc tangent of x. It's hold up. There you go. Okay, and then we have tangent, arc tangent, and then we need arc cotangent of x, and then arc secant of x, and arc cosecant of x. There we go. Okay. And then the reason I spaced them out like that is because they have the funky little habit of, guess what? These are all fractions. And so arc sine turns into 1 over the square root of 1 minus x to the power of 2. Cosine turns into negative 1 over the square root of 1 minus x squared. Tangent turns into 1 over 1, that's not 1, 1 plus 2 plus x to the power of 2. Cotangent is negative 1 over 1 plus x to the power of 2. Secant is 1 over the absolute value of x times the square root of x squared minus 1. And cosecant is negative 1 over the absolute value of x times the square root of x squared minus 1. And so you might notice a little pattern here. The co is always the negative version of the regular. So cosine is just the sine derivative, but negative. Cotangent, the tangent derivative, but negative. And so it makes it a little bit easier, because then you just have to remember the regular version, and then the fact that the other one's just negative. So if I know tangent, I know arctangent, the arctangent derivative. I technically also know the cotangent derivative, I just have to make it negative. So it makes it a little easier that way, which is really nice. My Oshi just got really active on Twitter for some reason. Hello? Girl, get yourself some sleep. Please. Okay. So. Then we have the distinct rules. So there are, like, distinct, like, rules on how you solve problems. Not just, like, oh, these are what they turn into. There's, like, if you have, like, a compound function. So, functions that have, like, multiple, like, steps, technically. So, x to the power of... Hold on, that's, Sorry, I not mean to cough on mic, I promise you. Okay, do here. Let's look at this real quick. So, looking at number 2. That's not what I want to pick up, excuse me. Looking over here at number 2, you can see that there is 2 x's in here. And then they're inside this parentheses with an exponent on the outside. So this is like 3 functions technically stuck together. And so you have the function 2x to the power of 2. Plus that, plus another function that's 3x to the power of negative 2. And those 2 functions combined then becomes the input for the next function that is the x to the power of 3. And so there's 3 different functions, so you have to break it down into the different functions in order to solve it properly. And so, for the most part, it's not that bad. Since they're just addition right there, we only have to treat it like it's in those first 2, like they're being added together, because they are, so it's fine. But when we're inside another function, like it is here, the whole thing combined is inside the function of x to the power of 3, then we have to do the chain rule. So, I'm gonna make this smaller again. Whee! Shun the math. Shun the math. Okay, I'm gonna say here. I try my best not to cover up the code. I tried hard not to cover up the Morse code, okay? I want y'all to look at it. I want you to see it. Wonder what it means. Implications. Okay. Wahoo! Yahoo! Okay. I gotta make it so you can see the screen again. Wahoo! Okay, so. We start with our general rules, which our rules include constant multiple. So, if we have, say, a, where a is any real number, times f of x, with f of x being a function, then the derivative is just a, that's a d, then the derivative is just a times the derivative of the function. Sorry, I'm trying not to cough on stream. Hold on, let me drink some water. I don't know, my throat is not being kind to me today for some reason. Wahoo! Okay. So, what I wanted to do. Thank you. And then, so that's the constant multiple rule. Then the chain rule, which was the one I was talking about for 2, so that's what we're going to have to use when we solve 2. But the chain rule is if we take, say we have g of f of x, and so the solution for f of x becomes our new input for the g function. In order to solve this and get our derivative, which is shown like this, then we're gonna want to do, we're gonna have to do the derivative of g, but leaving the f of x inside alone, and not solving the derivative for that yet. And then we have to multiply that answer by our derivative for x. And so we solve it with f still inside the g, not touching f at all, ignoring f's existence other than the fact that it stands for x, and solving g, and then solving f and multiplying the two together. I hope that makes sense. Okay, and then we have product rule. Product rule isn't too bad, honestly. So, product rule, hold on, okay, I have to make sure I put the derivatives on there. Product rule means that if we have a stylus that is actually turned on, if we have f of x times g of x, then the derivative of that is equal to f of x by itself, not touched. We're not touching f of x. Multiply that by the derivative of g of x. So then we solve g of x and times it by just f of x. And then we add that to our g left alone, g of x left alone, times our derivative of f of x. And so we take each part, we want the derivative of both of them, but we also want the normal of both of them. And we times the normal by the derivative of the other, and then add all of them together. And add those two sections together. And that's our product rule. So if we have two of them multiplied to each other, then we deal with that. So in our example with number 2, if it was 2x to the power of 3, or 2, I can't read this angle, 2x to the power of 2 times 3x to the power of -2, then we would have to use this rule. But because it's addition, then we just have to add it. Addition and subtraction, we just add and subtract as normal. Multiplication, division, and all that stuff is where we get a little funky with it, and where we have to do some things. Okay, last major rule is quotient rule. So quotient rule is if we have f of x up here, divide that by g of x down here. And then this whole thing we want the derivative for. That is going to equal a big funky thing. But it's really similar to what we just did with the product rule too. We want to take our bottom section, our g. We want to take our g of x. And we just want the normal g of x. And then we're going to times that by our... Sorry, I could tell I had a cough coming and I want to deal with it. We want to times that by our f prime of x. Then we're subtracting, not adding. We're subtracting this one. Subtract it by the f of x normal times our g prime of x. And now we're not done because we still have to do the bottom part, but the bottom part is super easy. Because the bottom part, we just take our g of x and we'd raise it to the power of 2. That's all we have to do if it's a quotient rule. Yeesh, I really need to drink water. My throat is very dry today and I don't know why. Okay. Ba-ba-da-ba-da-ba. So, these are like our big main rules for exponents. Not exponents, for derivatives. So we're going to use this to solve for our problems. And so we can figure out like what we need to do from there. So we're going to start with our first 5 problems. And then we'll move on from there. So I'm going to try not to look at the rules unless I have to. I might, just because it's a little wonky, but we've got y is equal to x sine of x over e power of 4x the power of 6. Now this has a few different things in it. So we're gonna highlight our what our like functions are. So we want to go from the innermost to the outermost. So we know that 4x, that is a function, because normally it's just e to the power of one thing, not e to the power of the equation of something. So we know that's a function. We also know that e, the power of that, is a function. We know that this is a function. X times sine x, that is our function. And then this whole thing is a function because it's inside our 6 to the power of 6. And so we have to start from all of these pieces. So a good way to do this is to write a like base one with just like just a few letters. So if we start, this would be equivalent to a y is equal to we have k of f over g of f of x over g of h of x. And so we want to start and figure out, like, okay, how do we solve it from there? So, some people like to do outermost to innermost. I like doing innermost first. So, having you can do this by having like a list of each one. And so if you take like, oh, this is, let's scoot up a little. This is the derivative of h of x. And this is the derivative of g of x. And the derivative of f of x. And then the derivative of k of x. And then finding where those go in our like derivative equation, which our derivative equation, we start with inside work out. We start with outside work inside. With that specifically, so k, our outside is 6, which is very similar to our our x to the power of n. Which, in that case, we'd take our 6... want to take our 6... and then our x to the power of... 5. Because it's 6 minus 1. There's that. And that's like our base one. But then inside it, we have to have our, like, our big long piece. Our quotient rule one. Right? So this would be our 6 x to the power of 5. F prime of x, if it was just the f x to the power of x times sine x. So sine x is cosine x. So x times that. The x just turns into a 1 because it doesn't have any... It's technically x to the power of 1. And so it turns to x to the... So it turns to 1 times x to the power of 0, which x to the power of 0 is 0. Anything to the power of 0 is 0. And so it just turns into a 1. But we don't have to write the 1 because that doesn't change our equation. So it just turns into our cosine of x. Our g of x, if we just have e to the power of x, is e to the power of x. And then our hx is 4 to the power of x, which is 4. Because it's, again, x to the power of 1. X, 4 times 1 times x to the power of 0. X to the power of 0 is 0. X, 1 times 4 is 4. That turns into just a 4. So those are our derivatives for all of those. Then we have to put them together. So, our derivative, like, all together, if we have our, we have our, we have our chain rule, and we have a quotient rule right there. So, we're going to want to start with the, blah, 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 blah. Okay, so. It's going to start with 6. We're going to start with 6. 6. And then, we're going to want F, G. This is going to get a little messy, but we'll see how bad it goes. So, we are going to want our our regular g times our f. So our regular g is e to the 4x. E to the 4x times the solved version of that, which is just cosine x. Cosine x. And then we subtract that by our x sine x. And then we times that by our e the power of 4x times 4. Because chain rule, we have to solve the first one. We solve the outside with leaving the inside alone, and then we solve the inside and times them together. So that is that. And then do that, and then this is up to a 5. And then underneath we want the bottom piece, the power of 2. So we have e to the power of 4x, the power of 2. And that is our derivative for our first question. Hopefully that makes sense to everybody. Okay. I'm gonna go a little bit faster just because I don't want to do every problem like that because it's gonna take forever because there's like 100 different practice problems I could do. So I'm not going to do that. But let's do number 2. So we have y is equal to 2x to the power of 2 plus 3x to the power of negative 2, the whole thing to the power of... So again, we're going to take our highlighter and highlight our functions. So we have a function here. We have a function here. And then this whole thing is a function of to the power of 3. And so again, the inside part is going to be the easiest to figure out because we just have to add the derivatives of both. And since we know that's a product rule, we can already start off with our 3 times our product rule, which 2x to the power of 2. We take the 2, drop it down, so it's 2 times 2, which turns into 4. And then 2 minus 1 is 1, so it's 4x. So we have 4x plus 3x to the power of negative 2. Negative 2 drop down, times 3 is negative 6. Negative 2 minus 1 is negative 3. So it's negative 6x minus 3. So we're going to take this negative, this positive, we're going to turn it into a negative. Negative 6x to the power of negative 3. That whole thing, since we did times 3, we want to take away take away 1, so that turns it into a 2. See? Like that. Real simple. Okay, what else we got? Y is equal to the natural log of cosine x. And so, again, highlight because I find it makes it a lot easier. There's 1 there. And then this whole thing is 1. So we've got two functions there. So This is another chain rule, so inside, outside. So we want to solve outside and leave inside alone. So the natural log of x is 1 over x, which turns this into 1 over cosine x. And then we times that by our solved inside, which the derivative for cosine is negative sine x. And so there is our solved number 3. Okay. 4. Y. Why are you being so stupid? Y of y equals secant x divided by ln x. And so we have 2 functions here, and so this is quotient rule, fairly straightforward. Quotient rule, we're gonna want to grab this, and we're gonna go. So we're gonna take our bottom ln x times our solved top, which what is the secant? It's secant squared times tangent? No, just secant times tangent. Okay. So this times our secx times tangent x, subtract that by our secant x times 1 over x, and the whole thing over ln x to the power of 2. Ta-da! Beautifully done. Actually, I could do 5 here. Okay. Okay. Let's see. Let's try. Let's do 5. So I should probably move this a little. Kind of hard to see 5. Yeah, it's getting the video's getting funky. Woohoo! Okay. We're all good? We're all good, okay. Okay, so 5 is a big one. Y is equal to the natural log of x plus 8, 5x plus I6, whole thing times tan dx. Okay. So this one is kind of layered. So it has a few different things. So first, we have our inside, our whole inside, which is important. We have our top part of our inside, and we have the bottom part of our inside. And then we have this outside bit. And so while it does look like confusing, it's just outside times inside. It's just our, like, this. It's just our yellow times our blue. It just means that our yellow is also a quotient rule. So our yellow is going to be long, but it's literally just yellow times blue. It's our yellow times blue regular, and then yellow regular times blue. Get what I'm saying? Let me write it out, because I'm confusing myself here, and I'm like, it's not that hard. Chill. At least not for me. I know that's a bad thing to say. It's like, oh, it's not that hard. Every person has different skill levels, which is fair. Just because I find it easy doesn't mean it's easy for you, and that is completely valid. But I do like math, that's why I'm studying it. As much as times as I'll say like, oh, I'm so mad, or I just hate math sometimes, I love it. It's amazing. I like solving them. I like doing stuff like this. I just hate the fact that I have to memorize it. I can't just have the notes in front of me the whole time. Because, like, real world settings, I could have the notes. It's gonna take me a little longer, yeah, but I'd rather have the notes and be, like, for sure what the issue is, what the problem is, and know if I'm making a mistake or not before I test it out and something goes wrong, or before I give it to a boss, you know? But yeah. Okay, so I'm gonna structure this one out a bit because it's kind of funky. Because this one we have chain. No, we don't have chain. We have product. So we're gonna have this is F, and this is G, and then this is H, and this is I. Okay, and so this turns F normal times G prime plus G normal times F prime, which F prime is actually just H normal times I minus H done times I, and then I to the power of 2. You see? So it's gonna look like this. Which means we're gonna have our F normal, which is our ln x plus 8 over 5x plus I to the power of 6 times our G solved, which G is actually, it has that 3 there. Well, no, that's still like one thing though. So our tan, that's we're gonna have 3. Our tan turns into no, because tan turns into something. Hold on. So this is 2 parts. So our G prime is actually our 3 times our and 2x times sec squared. Yeah. Yeah. So that times 3 tan 2x times sec 2x. And then times this add this to, we're gonna move it down. We add that to our G regular and then our funky stuff. So G regular is tan 3x times our chunky boy of H regular, which H is ln x plus 8 times our bottom solved, which if we solve the bottom, x to the power of 1, drop the 1, minus 1 from the top, which makes that 0, x to the power of 0, which turns it into 0. 5 times 1 is 5, plus pi to the power of 6. It does not have an x, therefore it is just a constant. So we just drop that entirely, and we have 5. That, and we're going to do that. And then we need to subtract that from, we need to subtract our 5x plus pi 6 times, we're going to get rid of this for right now. Not helping any. So turn to normal, please. I don't like the... I'm not used to it yet. Okay, that times our ln x plus 8. So ln of x is just 1 over x. And 8 is a constant, so we drop it. And then underneath we have our 5x plus pi to the power of 6, the whole thing to the power of 2. So that whole thing would be our answer. We're going to turn over to this. We're going to take this and we're going to go here. There we go. I think that's good. See? That's derivatives. They're not too hard, honestly. Like, again, I say this, but like, it depends on what's hard for you and what's not hard for you, so it's just kind of, it depends on the person, you know? Let's see. Did I do more stuff? Yeesh. So much on here. Oh, this has like 100. What? That one has 150. This one has like 48. Gosh, there's so many. Honestly, I don't know if I want to keep going. I've been kind of sick today. But I wanted to get some, like, practice in. And I feel better about it now, because, like, I treated this like I do during my, my recitations. When I have recitations for this class, I have a group of friends, who I've made from this class specifically. They don't quite understand it half the time. So I, as a education major, someone who's learning to teach students math, I act as the teacher and, like, teach them how to do it and, like, thoroughly explain it, and it seems to help them, and it also helps me better understand it. And that's kind of what I did this stream, is like, okay, I'm gonna kind of explain how it's done, break it down and all, because then it makes a little more sense in my head. And I hope it makes more sense in your guys' head. If you guys figured out how to do derivatives from this stream, thank you. You're welcome. I love you. If not, if you're just more confused, if you don't need to learn derivatives, I suggest you don't. Please run for your lives. I am gonna figure out who we're gonna raid right now, because I am done for right now. I'm just kinda just done, you know? Tired. Hmm. See. Who's live right now? Kyle's playing Lockdown Protocol. I think he's ending. Hold on. He's ending soon. Is he ending soon? I think he's ending soon. Some people are leaving, so I'm like... No, I think he's not ending. Okay, yep, he's not ending. So we're gonna hop in to his stream, treat him right, treat him well, make sure he's hydrated and he's good to go. I will see you all later, my magpies. You are amazing. I love you as always. Hold on. You guys are amazing. I love you all. And we're going to go ahead and raid over to Kyle. He is amazing. He is a magpie, and we love him. So we're gonna raid over into him playing Lockdown Protocol. He is drinking, so if you're uncomfortable with that, you can go somewhere else. But I am raiding into him. Thank you all so much. I will see you later, guys. Bye.